So inside here, components wise, because this is just a furnace AC setup system, the system does not have the heat pump ability where the condenser can produce heat and cool. So in this case, there's not a control board to do much of switching from cooling to heating cycle. So this is just straight cooling. So this have very minimal components. So this would be the contactor, this would be the capacitor, and this would be the compressor saver, or it's an add-on. The contactor operates both low and high voltage. The low voltage, when the thermostat tells it that I need you to operate, it closes the coil, in which create a magnetic field and pulls in the contact. And once it closes, it allows the high voltage to pass through. We go to the compressor and the fan to operate the compressor. And the capacitor, what this does, this is a run capacitor. It has two purposes. It assists the compressor and the fan in starting and maintaining the speed. Now, part of our routine checkup when we do a maintenance on the system, we check to see the condition of the contactor. Like in this case, this contactor has a lot of burn mark on it, so it's considered pitted. So at some point, you'll find that when it tries to energize, it won't make contact. So like at this point, this contactor is at the point of it will fail at some given point. We check the capacitor to find the ratings that are on it. As you can see on this particular one, there's a 45 plus 5. That means the 45 operates the compressor side of it and the 5 operates the fan side of it. Now it's rated in MFD. So we have meters that we can check to see the ratings on it in comparing to what it's supposed to be, and we determine if the capacitor is failed. Now it only gives you a 6% stress point. In this case is a 5%. Some is 6%. So anything below a 5% of the 45 or the 5, this capacitor is considered failed and needs to be replaced. Because what's going to happen at that point, the compressor or the fan will be doing more than what it's supposed to, because this is what assisted in running and maintaining the speed. So either the compressor or the fan will be running not as fast as supposed to, but it will be struggling, and in that case it's pulling more amp draw, so you're spending more on utility. And basically it's most older unit does not come with a start assist, which is called a compressor saver. So we traditionally add these to the capacitor when we find the compressor is drawing a higher amp draw, because what this does, it helps the compressor in the startup cycle to make sure it starts and it extends the life of the compressor. So at this point, I'm going to check the capacitor to see the condition and the ratings on it right now. So this is rated 45 and I'm getting 44, so that's telling me that the capacitor on the compressor side is still good. On the fan side, it's rated 5 and I'm getting 4.5, so it's still within that 5% range. So this capacitor is considered okay. Another part of our check is we check to make sure we have our valve covers on, and we look for any evidence of oil leaks anywhere. Whenever we see oil present, it usually indicates possible leak. We should prompt us to go a little further to make sure there's not a leak on the system. System typically should never have a leak. Once system is charged and operation, it should never lose refrigerant. So if you ever lose refrigerant, you have a problem. That means there is a leak somewhere on the system. Now, as far as operation, we typically take the startup amp draw for the compressor and the run amp draw. And as far as the condenser fan, we check the running amp of it and you usually find on the data plate, it gives you basic information of what we're looking for. In the case of the compressor, the maximum running amp should have been 14, maximum startup amp should have been 68. As far as the motor, it should be, let me see if I can find it here, fan motor is a 1.8 horsepower, maximum amp draw is supposed to be 0.8. So we rate whatever we find compared to the data plate, which tells us the condition of the compressor and the fan. So the fan, it was 0.8. So it's telling us our fan is perfectly fine. It's doing what it's supposed to. From the data plate, it was 0.8, and we're getting 0.8. Now check the compressor. So my compressor startup was 73, which on the data plate, I think it was 63 maximum. So my compressor startup amp on this is extremely high. So even though it has a compressor saver, that's telling me the compressor at some point will fail, because even with a compressor saver, the amp draw is extremely high. Now once it starts, the running is fine. The maximum was 14 and I'm getting 6.9. So oh no, running amp is perfectly okay. The operation on the inside to verify that we are getting good temperature split on the inside, and then present my findings to the customer.